pass through the ascending node just before midnight on March 7th. This is where it will be level with the Earth and Sun. On its orbital journey, it will pass through perigee, its closest distance to Earth, on March 19th. During this time, the Earth has now moved into its orbital location where the ecliptic nodes are in alignment with the new and full moon phases, and conditions are now right for an eclipse to occur. Within hours of this event, the moon will be in the new moon phase, causing a solar eclipse that will be seen only in the upper latitudes of the daylight side of the northern hemisphere. The moon's passing through the new moon phase a little before and just a little higher of the ecliptic node will cause its shadow to fall far north on the Earth. Any higher, and the shadow would pass over the Earth completely. Its horizontal alignment is perfect, but not so much vertically. This is typical for eclipses that occur early or late in the eclipse season. Let's take a closer look. But while the moon relentlessly orbits the Earth too continues its voyage around the sun and will pass through the vernal equinox on March 20th. As the Earth passes through the vernal equinox, we see that its polar axis is now perpendicular to the direction of sunlight. This causes the northern and southern hemispheres to have equal exposure to the sun, giving the Earth the same amount of daylight hours as it has nighttime hours. This is where the term equinox comes from, equal night. Just over 3 hours later, the moon will transit the descending node on March 21st, continuing to its lowest orbital point. Soon after, the moon will be at its furthest point from Earth, apogee, on April 1st. With the ecliptic nodes now at the ideal point for an eclipse to occur, the moon will be in the optimal position for a total lunar eclipse on April 4th during the full moon. This will be the third total lunar eclipse in a series of 4, known astronomically as a tetrad. As the moon moves into the Earth's shadow, it takes on a red glow. This is caused by the refraction of sunlight through the Earth's atmosphere, and the moon reflecting the glow of every sunrise and sunset simultaneously. As the moon continues on with clockwork regularity, the Earth too continues on its path around the sun, and the ecliptic nodes begin to move out of range of the new and full moon locations, causing the eclipse season to expire, only to renew 173 days later, beginning the cycle again.